students, today we are discussing torque from the topic system of particles. And what's the topic name, man? Thank you. System of particles and rotational motion, right? Yes. Hello students, welcome to today's session on torque, which is from system of particles and rotational motion. So yes, this torque, as we all know from lower grades, is the rotating force. The force which actually causes a rotation in a circular direction. Okay, so it is a rotational analog, which we can say it is a rotational analog of force, and it expresses tendency of force to cause the object to rotate about a given point, if that particular point can be called as the pivot. So like the object is pivoted along point P or along point, P. Yes. If this is a turning object, now for this object to actually turn, this should have a pivot. Pivot, that means it is the fixed point along which the turning actually occurs. That's known as pivot. So, and the object is known as pivoted. To investigate further, let us discuss an experiment. In this experiment, we are considering a rod which is pivoted at point O. Now, a force F is getting applied on it and at the point P. At the point P, a force F is applied. And as we all know, according to the conventional method, force will be divided into two components, sine and cos theta respectively. Cos theta of the force along the rod will be counterbalanced by the reaction force. Reaction force of the pivot, that means normal force. Normal force which the pivot is causing at the rod. And it cannot contribute in rotating the rod. The rod cannot be rotated as cos theta component is not causing the rotation. Yes. It is the component of F sine theta. Everyone must note it down that of the force which is perpendicular to the rod, responsible for the rotation of the rod. Moreover, farther is that point P from point O where force is applied easier, it is to rotate the rod. This is why handle on a door is attached as far as possible from the hinges, because the closer it is attached, the larger amount of effort or the larger amount of force will be required to actually cause the rotation, because torque is equal to R cross F. We all know where R is the position from the pivot where the force acts. Magnitude of torque of force is proportional to the product of the distance of point of application of force from the pivot. That's what I have said. And magnitude of perpendicular component, which is F sine theta of the force. Now, denoting torque, the distance of point of application of force from the pivot by R, we can write torque is directly proportional to RF sine theta, because cos theta is not causing any contribution. Similar analogies can be found into the next diagram, where we can see torque is equals to R cross F. And that's how the theta inclination is occurring. The theta is getting inclined and the force is getting applied on the point of application, that means the pivot. Let us consider one of the questions which is also dealing with certain kinematic quantities which we can find in circular motion or in torque. A wheel is rotating. A wheel is rotating with angular velocity. Okay, angular velocity has been given to us. So it is subjected to uniform acceleration. Uniform angular acceleration has been quantized. And how much angular velocity will be required after time is equal to 10 seconds? How much angular velocity does the wheel acquire? Does the wheel acquire after time is equals to 10 seconds? That's the first part. Now, for calculating it, we must know that angular velocity is equal to omega naught plus alpha t. That means this is just as in corollary with the rectilinear motion which we are writing v is equal to u plus at. Substituting the values, we will get 2 plus 2 into 10. That means 22 radian per second. In the second part, these are certain formula and derivations associated will be discussed in my upcoming sessions. Because initial position or the initial position is to be 0. Substituting the values, this will be 20, this will be 12. 12 into 10 will be 120 and half of 120 will be 60 radian. Now, in one revolution, we are using the unitary method of grade 10 mathematics. The wheel is causing, the wheel rotates through 2 pi radians. So what will be the number of revolutions, which could be termed as n? Very easy. We just need to substitute a known formula, which is theta upon 2 pi. And this formula also comes up across when students are discussing units and dimension, just after the parallax method. 60 by 2 pi. That's your answer. Just matching the option, we are getting 60 by 2 pi. 2 into 180 can also be written. And 60 by 2 pi is also the right answer. So keep practicing, students. I'll be seeing you in the next session. Till then, all the best. And if you have any doubts regarding any topic in physics, please revert to my Urban Pro profile. Thank you so much.